All right, continue with chapter 13. We're going to talk about concentration of solutions today. Now, when we talk about solutions, we can say, oh, there's a lot of stuff in there, or there's just a pinch. Well, we can be exact. We can determine exactly how much solute is dissolved in the solvent, and that's its concentration. Okay. Again, we discussed solubility, how much stuff dissolves, and we've talked about it qualitatively. Like, it has, if it's saturated, which is a quantitative number, unsaturated and supersaturated. We also talked about, does it dissolve anymore? That's something you can see. So what we're going to do now is we're going to talk about it in specific amounts. Again, you're not going to just say, oh, it's concentrated. That means it has a lot of stuff in it. We can actually determine when you add a certain amount of substance, a measured out amount of substance, what the concentration of a solution can be. And there's some different ways of doing that. One's called mass percentage. And you'll see that if you have your cleaning products at home, you can see they'll give you a percentage. You'll also see this in medications. Parts per million and parts per billion. These are done a lot with testing. If you are water quality and stuff, they'll say, the copper is, 1 part per million or 1 part per billion or something like that. So that's a common way. Mole fraction is something I'll show you. It's the moles of the solute divided by the moles of the solution. And again, I'll show you how to do that. There's something called molarity, which is real common in chemistry. Most of the solutions we have, that's how we get them. And when I make up solutions that we do in labs, we do molarity. And molarity is moles divided by liters. And then there's molality. Molality is similar to molarity. And if you're talking about water, they're the same. But molality is more, we'll talk about later, what they call colligative properties. It's where we interfere with the interactions in the particles, and that's where you get molality. And the only difference really in there is molarity is liters of solution, molality is kilograms of solvent. So they're a little bit different. Okay, so we're going to do mass percentage. What we're doing is we're talking about out of 100. So let's say you have 100 grams of water. Well, let's say we got 97 grams of water. We'll say 97 grams of water, and we add 3 grams of salt to it. That solution is 3%. 3% is salt and 97% is water. Okay, so that's mass percentage. It's usually not that easy to figure out. And one of the most common mass percentages you'll see if you're in the medical field is when they give you saline solution. Saline solution is 0.9% salt. Okay, less than 1%. And the reason why they give that to you is that's what your normal body fluids are. I mean, you can't just give a person water. If somebody's dehydrated, yeah, you can drink water, but when they give them IV fluids, they don't just give them water. If you did that, then you'd be low on your electrolytes, and that wouldn't serve the purpose. They give you 0.9% saline solution because that's what your normal body fluids are. Okay, so you take the ratio of the mass of the solute to the total mass of the solution, and then you multiply by 100 to change it to percent. Okay, so it's the mass of the solute over the mass of the solution. The nice thing about this is you don't have to change it to moles. These are probably the simplest of all the solution concentration problems to do. Okay, so to figure out the mass, you take the mass of the solute, over the mass of the solution, and then you multiply by 100. Okay, here's an example. What is the percent mass of a solution if 56 grams of solute are dissolved in 425 grams of solvent? Okay, to solve this, 56, and now I need the mass of the solution, so I'm going to have to add these two together. Okay, so 56 mass of solute, and then this is the mass of the solution. I have to add them. Now, sometimes they'll say 56 grams of solute dissolved in 425 grams of solution. If it says that, then you don't have to add them together. But in this case, it lists them separate, so you got to add them. So when you take this divided by this, you get 0.116 or 11.6%. So this solute, and again, it doesn't matter what solute it is. Okay, you don't have to change it to moles, so you don't have to find its mass. It's just whatever it is here, so you don't even have to really have a name of it. But whatever the solution is, it's 11.6%, whatever the solute is. Okay, that's pretty strong. Okay. Okay, what is the percent mass of 11.2 grams of calcium chloride if it's dissolved in 158 grams of solution? So this was, I was talking about the different one, okay? So this one says solution, so I don't have to add them together. So all I'm going to do is take 112 or 11.2, sorry, 11.2 divided by 158. I don't have to add them like I did here because they're not listed separate. They give me the mass of the solution. So again, I get 0.071, so it's 7, I move the decimal over to 7.1% calcium chloride, the solution, whatever it is, okay? So that's when you're doing percent mass, these are the easiest problems. Again, the trickiest part is looking, does it say grams of solvent or does it say grams of solution? If it says grams of solution, you don't have to add them together. If it says grams of solvent, you got to add them together, okay? That's the first concentration. That's percent by mass. Okay, parts per million and parts per billion. It's still the mass of the solid kind of deal. Mass of the component, total mass. So you solve them the same. But if it's parts per million, you multiply by 10 to the 6th. If it's parts per billion, multiply by 10 to the 9th. Okay, so it's still the same thing. And again, a parts per million, if you want to get an idea, if something is 2 parts per billion, let's say you have 1 billion tennis balls, and you take 2 of the tennis balls out and you put 2 softballs, I don't know, and the softballs are going to represent your solute. So 2 of them and the rest of them, that would be 2 parts per billion. It's not very big. But the funny thing about it, when you're looking at water quality, parts per billion, just a little bit can cause a problem. Like with poisons, you know, when they're testing to see if there's arsenic in the water or whatever. So it seems like that, you know, if it's 1 part per billion, take 1 billion particles and take out 1 and replace it. It doesn't seem like that would be a lot, but it is in some cases. They can cause some problems, okay? But anyway, that's parts per million and parts per billion. You do the same thing, but you just multiply by either 10 to the 6th for parts per million and 10 to the 9th for parts per billion, okay? Same kind of deal, all right? We won't spend a lot of times doing that. If you work in the medical field, sometimes you work with that, but honestly, this is more like analytical chemistry when you're analyzing water samples and other samples for certain things, okay? Okay, mole fraction. Mole fraction is the ratio of moles of a substance to the total moles of the solution, okay? And you use mole fraction to figure out a couple different things that we'll talk about later, okay? It doesn't matter if it's a solute, if it's for the solute or for the solvent. So you can figure out the mole fraction of water, if water is your solvent. You can figure out your mole fraction for salt, if that's what you're adding to your thing, okay? You can do for either or, but what you do to solve for it is you take the moles of the component. Okay, let's say we're talking about, we're going to do the mole fraction for water. We're going to take the moles of the water. Let's say it's 100 grams of water. We would change 100 grams to moles. Take 100 divided by 18. Okay, the total moles, well, what we do if I'm doing a saltwater solution, I take the moles of the salt and the moles of the water and add them together. So if you're doing a mole fraction for the solvent, you take the moles of the solvent divided by the moles of the solvent and the solute added together. If you're doing the moles of the solute, like salt, you would take the moles of the salt divided by the total moles, okay? So you have to, when you do mole fraction, you have to find the moles of the solute and the moles of the solvent. Most of the time, your solvent is water. But again, when you're trying to do it, all you do is take the amount that they give you and you divide by its formula mass. So if it's water, you divide by 18. If it was salt, you take the amount of salt you have and you divide by 58.5 because that's the mass of salt. Okay? All right. So, and then the last two are molarity and molality, and these are the ones I was telling you about that are very similar to each other. You can see it's moles of solute, liters of solution, kilograms of solvent. So this one's volume and this one's mass. Okay? And if you're talking about water, they're the same. When you do this, it says be careful of your penmanship. Molarity is big M, molality is little m. How I remember, you know when you used to write Mr. when you were a kid, you had to make sure it was a big M and a little r? Well, there's the big M, there's the little r. I don't know if that helps you. Like I said, I have all these weird things to remember things, and it's because I'm old. You guys probably can just remember molarity is big M and molality is little m. I don't know. I just thought I'd show you that. Anyway, so be careful when you draw these, okay? But this is moles of solute, and in both cases, whatever your solute is, you're going to have to change it from grams to moles, like we've done a bunch of times. In chemistry, it's a common thing. If you get grams, you got to change it to moles, okay? So molarity is moles of solid per liter solution. And it has to be, most of the time it's listed in milliliters, especially like when we do stuff in the lab, we use a graduated cylinder. That's 100 milliliters, okay? That's what we usually use is milliliters. So if it's in milliliters, you got to change to liters, which is really simple to do. All you do is move the decimal over 3, okay? If you're doing molality as moles of solid, again, you got to change to moles of solid. So in both cases, and then you'd use kilogram solvent. So again, we usually measure things in grams. Excuse me, you guys. You guys, shut up! Sorry, I have pain in the butt dogs. I don't know if you guys do too, but I do. Anyway, you find moles of solute and you change it to kilograms of solvent. And again, most of the time we measure with grams. So move the decimal over 3. So it's kind of the same process. And again, if you're talking about water, it's going to be the same number. Okay. So molarity versus molality. When water is a solvent, dilute solutions have the same molarity and molality. Okay, because the reason for that is a milliliter of water equals a gram of water. So the two of them are the same. Okay. It can, molality, which is the kilograms, doesn't vary with temperature because the mass doesn't change. But molarity can. Okay, volume can change as you heat something up. You know, the volume can change. Or if you cool it down, the volume can change. So that's why molarity can be a little off, but in most cases, it's going to be the same number. Okay, so here, we're going to find the molarity of a solution. We have 25 grams of calcium chloride dissolved in 600 milliliters of water. The first thing we have to do is we have to find the moles of calcium chloride. Okay, so all we have to do there is divide by its formula mass. Take 25. 1 mole of calcium chloride has a mass of 111 grams. Remember, you should have an app on your phone. For those of you that's taken this class last semester, we downloaded an app. It's called CCM, CMM, sorry, calculated molar mass. You can download it. It's an app. It tells you. So all you'd have to do is type in CaCl2 and it would tell you its mass is 111 grams. If you don't have that, all you have to do is take 1 calcium, which is 40, and 2 chlorine, which is 71, and add them together. It's just what it weighs, okay? So 1 mole is 111 grams. So what I've done so far is I found the moles of calcium chloride. All right, and then I have to divide by liters of solution. So if I have 600 milliliters, move the decimal over 3. It's here, move it over here. So it's 0.6 liters. That's all you have to do. So now I'm just going to take 0.225, my moles, divided by my liters. Okay, that's how you find molarity. And again, molarity is big M. All right, so this solution, if I take 25 grams of calcium chloride and I dissolve it in 600 milliliters of water, its molarity is 0.375. Okay, and you might not think that's very concentrated, but something that has a molarity of 1 is actually pretty strong. So it's not as dilute as you think, I guess. Okay, for molality, you take 35 grams of Na2O is dissolved in 584 grams of water. So again, find moles again. Take 35 grams of sodium oxide. Its formula mass, what it weighs, is 62. Give me that. Oh. Squeaky balls. Come here. Thank you. Toys. Okay, so 35 divided by 65 gives you 0.565 moles of sodium. And again, we need kilograms. So if it's grams, move it over 3, 0.58, and then just divide. Take your moles of sodium oxide and divide by your kilograms. And then you get little m, okay? Which is easy to tell the difference between big M and little m when you're typing, but I always make my little m with 3 lumps like a cursive because it's hard to tell the difference, okay? Okay, how many grams of, okay, so sometimes you can do them a little different. You can do grams of potassium sulfate. How much? Now I'm going to go backwards. I need to make a solution. And you know what? I'm going to run out of time. So I'm going to leave it off here because I'm going to show you this because this is what I do all the time when I set up labs. This is, I need this solution. And so I need to figure out how to make it. And I'm going to show you guys how to do that as well. But I'm almost at 15. Probably would have got done if I wouldn't have had dingbat dogs. Sorry about that. But again, we'll pick that up next time.